Greetings, ladies and gentlemen. In this video, we are going to start solving this past paper, which is the Science Paper 2, GCE. Science Paper 2 is the chemistry. Okay, without wasting much of our time, let us begin. Question A1, which branch of chemistry would a grade 12 learner intending to become a pharmacist study? A. Analytical chemistry. B. Biochemistry. C. Organic chemistry. D. Physical chemistry. Okay, so ladies and gentlemen, to answer this question, we are going to consider each and every branch of chemistry. So let us start by describing pharmacy. So pharmacy extremely depends on understanding the structures, synthesis, and properties of organic molecules, as most drugs are organic compounds. So we have seen that pharmacy extremely depends on understanding or knowing the structures and synthesis and properties of organic chemistry. Let us also describe biochemistry. So biochemistry deals with chemical processes within living organisms. It also involves the study of how drugs interact with the body. Okay, let us also look at analytical chemistry. So what is analytical chemistry? So an analytical chemistry involves analyzing of substances to determine their composition. Okay, to determine their composition. Let us also look at physical chemistry. Physical chemistry deals with the principles of physics applied to chemistry. Okay, so ladies and gentlemen, we have seen that a learner intending to become a pharmacist need to study organic chemistry as his prerequisite subject or course, because most of the drugs are organic compounds in nature. So therefore, our correct answer here is organic chemistry. Without wasting time, let us move to the next question, which is question A2. Question A2 reads, which of the following shows the correct basic unit of matter contained in the stated substances? A. Substances, boron, basic unit of matter, ions. B. Substance, mercury, basic unit of matter, molecules. C. Substance, methane, basic unit of matter, atoms. D. Substance, neon, basic unit of matter, atoms. Okay, so ladies and gentlemen, we need to remember that the basic unit matter of in neon is the atom, because neon is a noble gas and it exists as an individual atom rather than a molecule. Okay, now if we look at A, boron, this is a neutral atom or an individual atom. So therefore it should not contain ions. Okay, it should not contain ions. Let us also look at mercury. Mercury, this is an element if we check from the periodic table. So therefore, this one is not made up of molecules. Let us look at methane. Methane is a compound. So therefore, this compound should contain ions or molecules. But we have seen here it is showing atoms. Then neon is our perfect answer. Neon is our perfect answer. And the reason why we are saying so, we have seen that neon is an individual atom or neutral atom. So therefore, neon should contain atoms. Okay, our correct answer therefore is D. We move to the next question, which is question A3. Question A3 reads, the following diagrams show volumetric apparatus. Which apparatus measures only approximate volumes of liquid? Okay, so To answer this question, let us understand let us understand the meaning of precise measurements. So precise measurements are exact and accurate measurement with the little to no room for error. So precise measurements have no room for errors. Then approximate measurements are close to the actual value but not exact. So we have seen that approximate measurements are not exactly. Okay, approximate measurement are not exactly. Okay, so therefore, the apparatus that can help us to measure approximate volumes here is beaker. So beaker is an approximate. A beaker is an apparatus that can be used to measure approximate volume. We shift to the next question, which is question A4. Which mixture can be separated into its components by adding water, stirring, and filtering? A. Iron and sodium chloride. B. Iron and sulfur. C. Potassium carbonate and calcium nitrate. D. Sodium chloride and copper 2 sulfate. Okay, so the compounds that can be separated by by adding water is iron. Iron is insoluble in water. Okay, iron is insoluble in water, and sodium chloride is soluble in water. So therefore, we have seen that the criterion being used here is solubility. So we have seen that iron is insoluble, then sodium chloride is soluble in water. So therefore, uh, these two can be separated by adding water, stirring, and filtering. In short, these two can be separated by using filtration. We are done with this question. Let us move to the next question. We move to the next question, which is question A5. Question A5. Question A5. An atom of an element R has the electronic configuration 283. Which of the following statements about the element R is correct? It forms an ion of charge 3. B. It forms an ion with the electronic structure of neon. C. It is a non-metal. D. It reacts with the metals. Okay, it reacts with the metals. So if we look at the electronic configuration of the given element, we can see that it has 3 electrons in the outermost shell. So therefore, it is obvious that this element is coming from group 3. So therefore, this one is capable of forming forms ion with electronic structure. Forms an ion with the electron structure of neon. Okay, so this is not our correct answer. I thought this is positive. I have just seen it here. This is negative. So this is not a cation. So this is not our correct answer. This is not our correct answer. And if we look at this one, see, the electronic structure, this electronic structure is meant for aluminium. Aluminium is a metal. So this is not a non-metal. Reacts with metals? No. Okay. Our correct answer is B. Our correct answer is B. So if we remove 3, we are going to remain with the 10. And if we look at neon is a noble gas. Neon is a noble gas. So therefore, its outermost shell is full. So neon has 8 electrons in the outermost shell. So our correct answer should be B. I made the mistake here. I didn't see that this is negative. I thought this one is a positive. Okay, so our correct answer is B. We shift to the next question, which is question A6. Question A6, identify the diagram in which a pure element is in a solid state. Okay, in which a pure element is in a solid state. An element consists of pure particles, which are atoms of the same type. So we have seen that here we have two types. Here we have two types. Then here, yes, quite alright, this is an element. Now, according to our question, the question is very categorical. The question is saying in solid state. So if we look at this one, maybe it is in gas state. This one being particles are spacely packed. Okay, particles are spacely packed. Let us consider this one. This is not an element. Reason being, we can see two types of particles, black and white. So therefore, this is not an element. Quite alright, this one is in solid state, but this one is not an element. So an element is this one. Reason being, particles are closely packed. At the same time, this box has same type of particles. Our correct answer therefore is C. Our correct answer is C. We shift to the next question, which is question A7. Question A7, which of the following pairs of compounds would react together to form an insoluble salt? Okay, to form an insoluble salt. So to answer this question, we need to remember that sodium sulfate and lead nitrate form sodium sulfate and insoluble salt that precipitates. Okay, the other reactions produces only soluble salts or neutralization products. So we have seen that the pair that will form an insoluble salt is sodium sulfate is sodium sulfate and lead nitrate, which is C. We are done with this question. Let us move to the next question. We move to the next question, which is question A8. Question A8. A given sample solution was tested for presence of an ion using dilute hydrochloric acid. Evanescence was observed. Predict the anion present in the sample solution given. A. Carbonate ion. B. Chloride ion. C. Nitrate ion. D. Sulfate ion. So guys, once we talk about an ion, we are simply talking about a negative charge. Now they want us to give the test for this charge. So carbonate ions react with dilute hydrochloric acid to release carbon dioxide gas, which causes evanescence, bubbling or fizzing. Okay, bubbling or fizzing. So therefore, this is a distinct and easily observable reaction. Our correct answer is carbonate ion. Our correct answer is carbonate ion. So the test for carbonate ion, it produces carbon dioxide and causes evanescence. Okay, produces carbon dioxide and causes evanescence. We move to the next question, which is question A9. Calculate the relative formula mass of ammonium sulfate. The relative formula mass of ammonium sulfate. So let us begin by writing down the chemical formula here. So as we can see, we have 3 atoms of nitrogen. 3 atoms of nitrogen, and the mass number of nitrogen is 14. Plus, we have 12 atoms of hydrogen. Why are we saying so? 3 times 4 is equal to 12. So we have seen that we have 12 atoms of hydrogen, and the mass number of hydrogen is 1. The next element is phosphorus. we have one atom of phosphorus, and the mass number of phosphorus is 31. The next element is oxygen. We have 4 atoms of oxygen, and the mass number of oxygen is 16. Let us evaluate. 3 times 4, 3 times 4 is equal to 42. 12 times 1 is equal to 12. 1 times 31 is equal to 31. 4 times 16 is equal to 64. 42 plus 12 plus 31 plus 64. We are going to get 149. 149 is our correct answer. So therefore, our correct answer here is D. Our correct answer is D. We move to the next question, which is question A10. Question A10. A limestone decomposes to calcium oxide and carbon dioxide when strongly heated. Given that 500 grams of limestone was decomposed, calculate the mass of calcium oxide produced. Calculate the mass of calcium oxide produced. So what are we going to do to calculate the mass of calcium oxide produced? Okay. So to answer this question, we need to remember. So last time we looked at the reactions. We looked at 20 reactions before constructing chemical formula, and this one was on number 12, thermal decomposition. So this is the thermal decomposition. Okay, this is thermal decomposition. So therefore, if we decompose limestone, so limestone is a common name, scientific name calcium carbonate. Okay, calcium carbonate. We are going to produce calcium oxide plus calcium plus carbon dioxide. We are going to produce calcium oxide plus carbon dioxide. Okay. So we are going to use the law of proportionality. The relative formula mass of calcium carbonate is 100, and the relative formula mass of calcium oxide is 56, or the molar mass of calcium oxide is 56. And the molar mass of calcium carbonate is 100. And we have been given 500 here as the mass of limestone. So we are going to write 500 here. We write 500 here. Then here we are going to write X. Let us do a cross multiplication. We do a cross multiplication. So we are going to say 100 times X. We are going to get 100X. 500 times 56. So we are going to divide both sides of the equation by 100. Here divide by 100, even here divide by 100. Then we are going to get 280 grams. 280 grams. So therefore our correct answer here is 280 grams, which is C. We are done with this question. Let us shift to the next question. We shift to the next question, which is question A11. Question A11. The following graph was obtained when powdered calcium carbonate of equal volume and the mass was reacted with hydrochloric acid of different concentrations. Identify the graph which presents the reaction between powdered calcium carbonate and hydrochloric acid of the highest concentration. So this question is talking about how concentration affect the rate of reaction. Okay, so what we'll do, we are going to identify this time, or we are going to demarcate time. So before we demarcate time, we need to remember that increasing the concentration increases the rate of reaction. So if we if we increase the concentration, we are also going to increase the rate of reaction, because more particles lead to more frequent collisions. Okay, so therefore we know that higher concentration, higher the rate of reaction. The higher the concentration, the higher the rate of reaction. The lower the concentration, the lower the rate of what? Reaction. Okay, so what we'll do, let us demarcate time here. So we have seen that we have this time that has elapsed. Okay, we have this time that has elapsed. So we have seen that according to reaction, according to, so the question is saying, the question is saying which identify the graph which represent. So according to graph D, when this time elapsed, this volume produced. Okay, this volume produced here. Graph C, when this time elapsed, this volume produced here. Graph B, when this time elapsed, this volume was produced. Then A, when this time elapsed, this volume was produced. So to identify the graph with the highest concentration, we are going to pick one with the highest volume. So we have seen that the one that is showing highest volume is A. So therefore, A has the highest concentration of reactants. Okay. So therefore, our correct answer is A. Our correct answer is A. The higher the concentration, the higher the rate of what? Reaction. We move to the next question, which is the question A12. Question A12, how does a catalyst increase the rate of chemical reaction? It does by A, increasing the activation energy, B, lowering activation energy, C, lowering the kinetic energy of the reacting particles, D, reducing the frequency of collision of the particles. Okay, let us see. Let us explain the law. Let us explain the role of a catalyst in the reaction. So a catalyst increases the rate of chemical reaction by lowering the activation energy, making it easier for reactant particles to react. So activation energy is like a path used by the reaction. So a catalyst will shorten this path, thereby making the reaction easy or quick or fast. It provides alternative reaction pathways without being used up. Okay, so we have seen the normal activation energy. So this is the normal activation energy without a catalyst. And after adding a catalyst, the activation energy has been reduced. Okay, the activation energy has been reduced. So no wonder we are saying a catalyst reduces activation energy. So our correct answer is B. It lowers activation energy. We move to the next question, which is question A13. Question A13 reads, identify the correct electronic configuration of an element used to treat water. So the element we are talking about here, we are talking about chlorine. Chlorine is an element used to treat water. And the electronic configuration of chlorine is 287. 287. We are done with this question. Let us move to the next question. We move to the next question, which is question A14. Question A14. The following diagrams show different experimental setups used to investigate the conditions necessary for corrosion of iron metal to occur. Okay, so here we have layer of oil, previously boiled water, iron nail, boiling water. Here we have boiling tube, iron nail, water. Boiling tube, iron nail, salt water. Dry cotton wool, iron nail, boiling water. The question continues. Predict the experimental setup in which the iron nail will corrode the fastest. Okay, so ladies and gentlemen, we need to remember that an iron nail will corrode faster in salt water than in plain water because salt increases the conductivity of water. Salt increases the conductivity of water. So therefore, our correct answer here is D, having salt water. So in this experimental setup, the iron will corrode the fastest. Okay, our correct answer is C. We move to the next question, which is the question A15. Question A15 reads, in which of the following pair of reactants will a displacement reaction take place? Okay, so guys, to understand where displacement reaction will take place, we need to look at the reactivity series, the reactivity series of the elements given. So potassium is more reactive than sodium. Okay, so this is the reactivity series. This is the reactivity series. So we are going to start with the D. So for displacement reaction to take place here, for displacement reaction to take place, this ion should be more reactive than zinc. But we have seen that zinc is more reactive than iron. So D is not our correct answer. Let us consider this one. Copper. Copper should be more reactive than magnesium. We have seen that magnesium is more reactive than copper. So C is not our correct answer. We move to B. Ag. Ag should be more reactive than copper. But we have seen that copper is more reactive than Ag. We come to A. A, we have aluminium, here we have magnesium. So magnesium should be more reactive than aluminium. Yes, it is true. Magnesium is more reactive than aluminium. So this is where displacement reaction will take place. Our correct answer is A. Our correct answer is A. We move to the next question, which is okay, this is what we move to the next question. We have already answered this one. We move to the next question. Which is the question. Let me remove this one here. Let me do this. Okay, question A16. The diagram shows the collection of gas P during its production. What interpretation can be drawn from the method of collection of the gas? It has a density equal to that of air. B, it is denser than air. C, it is less dense than air. D, it is slightly soluble in water. Okay, so guys, let us come back to this slide. So we need to remember that if the gas collected is less dense than air, the best method is upward delivery. Upward delivery is also called downward displacement of air. Okay, so therefore, the one characteristic of the gas being collected here is it is less dense than air. So therefore, our correct answer is C. Our correct answer is C. We move to the next question, which is question A18. Question A18. The chemical compound which can best be used to make hand sanitizer is okay. So guys, we need to remember that the best chemical compound that can be used to make hand sanitizer is alcohol. Okay, do we have alcohol here? So A, this is not an alcohol. Reason being, we can see that one hydrogen is missing here. B, this is not an alcohol. C, this is carboxylic acid. This is carboxylic acid. Hydrogen is preferred to as a clean. Okay, which question are we answering here? So okay, so our correct answer here is D. So D is alcohol. Our correct answer is alcohol. We move to the next question, which is question 19. Sorry, I skipped question 17. Question A17. Why is hydrogen referred to as a clean gas? A, burns in oxygen to give more energy. B, does not pollute the environment. C, has no impurities. D, it is not a harmful gas. So the reason why hydrogen is referred to as a clean fuel is because it doesn't pollute the environment. So as hydrogen is used as a fuel, it doesn't produce harmful pollutants, or it doesn't pollute the environment. So therefore, we have seen that hydrogen is considered to be a clean fuel. Okay, it does not pollute the environment. So don't get confused here. D is saying it is not harmful. It is not harmful. There are other fuel that are not harmful, but they are capable of producing pollutants, pollutants that may pollute the environment. So our perfect answer here is B. Our perfect answer is B. Question 18, we have already answered question 18. Our correct answer here is alcohol, which is ethanol. Okay, the name of the alcohol we are talking about is ethanol. So alcohol is the one that is used to make hand sanitizer. Alcohol is the one that is used to make hand sanitizer. Our correct answer here is alcohol. Okay. We shift to the next question, which is question A19. Question A19. Large petroleum molecules undergo cracking to produce smaller molecules which are more useful. What would be product X when hydrocarbon is cracked according to the following reaction? So we need to remember that cracking involves the breaking down of hydrocarbon. Cracking involves the breaking down of hydrocarbon. So we have seen that the number of atoms here is the number of carbon atoms is 20. The number of hydrogen atom is 42. And we have the compound here. This one has four number of carbon, and 6 and 10 as the number of hydrogen atoms. So therefore, what we do, we are going to come up with the equation. We are going to count the number of hydrogen atoms. The number of hydrogen atoms. So we are going to say 2x plus 10, 2x plus 10, 2x plus 10, 2x plus 10. So this is 10 we are talking about, plus 2x is equal to 42. We group the like terms, 42 minus 10, we are going to get 32. Here divide by 2, even here divide by 2. The value of x is equal to 16. So therefore, the compound that is supposed to be here should have 16 number of hydrogen atoms and 8 number of carbon atoms. So therefore, our correct answer here, our correct answer is C. Our correct answer is C. We are done with this question. Let us move to the next question. We move to the next question, which is question A20. The diagram shows part of a polymer. Which of the following monomers would be used to form the polymer shown? Which of the following monomers would be used to form the polymer shown? Okay. So we have seen that here we have chlorine, hydrogen, chlorine, hydrogen, chlorine, hydrogen. So therefore, the perfect or the suitable monomer that can be used to form this polymer is polychloroethene. Polychloroethene. I mean the what? The polymer is polychloroethene. Then the monomer is this one. The monomer is chloroethene. So chloroethene here is C. Sorry, is A. Chloroethene is A. Chloroethene is A. So the reason why we have not chosen this one is this one is an alkane. We are looking for alkene. So this is our alkene. We can see a double bond here. We can see a double bond here. Okay. This is our correct answer. Let us shift to the next question. We shift to the next question, we shift to the next section, which is section B. Section B, answer all questions in this section. Write your answers in the spaces provided in this question paper. B1, a box of chemicals in a laboratory has the following symbol attached to it. A, Roman numeral 1, describe the nature of chemicals in the box related to the symbol. Okay, so we can see that this is a fire symbol. Now they want us to describe the nature. So the fire symbol on a chemical container indicates that the substances inside are flammable or combustible or otherwise pose fire hazard. So the fire symbol indicates that the chemicals inside are flammable or combustible, or they can cause fire. Okay, they can cause fire. So we are going to say it is flammable or combustible, or it can cause hazard. We are done with this question. Let us move to the next question, which is question A, Roman numeral 2. Write a laboratory rule that is observed when handling chemicals in this box. So what laboratory rules do we need to observe when handling chemicals in this box? So when handling chemicals labeled with the fire symbol, always prevent ignition sources. Okay, So we need to prevent ignition sources. Ensure proper ventilation. We need to ensure proper ventilation and use appropriate personal protective equipment, PPE, to minimize fire risks. Okay, or to minimize fire ignition. To minimize fire ignition. So these are some of the laboratory rules that we need to consider when handling chemicals in the given box. So therefore, we are going to say use appropriate personal protective equipment, PPE, to minimize fire risks. Okay. Without wasting time, let us move to question B. Question B, when a bottle of ammonia is opened with a few minutes within when a bottle of ammonia is opened within a few minutes, its smell spreads throughout the laboratory. Smells throughout the laboratory. B. Roman numeral 1. Name the process responsible for the evenly spreading of smell of ammonia solution. So the process that is responsible here is diffusion. The process that is responsible is diffusion. What is diffusion? Diffusion is the movement of particles from the region of lower concentration to the region of higher concentration. Roman numeral 2, describe the process responsible for the even spread of the smell of ammonium solution. So the process is diffusion. Diffusion is the movement of particles from the region of higher concentration to the region of lower concentration. We are done. Let us move to the next question. We move to the next question, which is the question B, Roman numeral 2. Relate the evidence which the process named in B Roman numeral 1 provides to the kinetic theory of matter. So before answering this question, what the kinetic theory of matter says. So all matter is made up of tiny particles, atoms or molecules. All matter is made up of tiny particles, atoms or molecules. How diffusion supports this? So when the ammonia gas spreads out, diffuses in air, it shows that particles of ammonia are moving on their own. Okay, particles of ammonia are moving on their own, which proves they have kinetic energy and are in motion. So we have seen that diffusion supports the kinetic theory of matter by showing that particles are in constant random motion. It proves that particles move from higher to lower concentration, move faster at higher temperature, and behave differently in gases and liquid. Evidence that matter is made up of tiny and uh, moving particles. Okay, so therefore we are going to say diffusion supports the kinetic theory of matter by showing that particles are in constant random motion. We are done with this question. Let us move to the next question. We move to question B2. Question B2 reads, the following diagram shows a piece of apparatus used in the laboratory. Question A, name the piece of apparatus shown in the diagram. So the piece of apparatus shown here is a separating funnel. So this is a separating funnel. Okay, this is a separating funnel. So we are going to say separating funnel. We are done with question A. Let us move to question B. Roman numeral 1. Identify one property of the mixture separated by the piece of apparatus named in A. Okay, so the property of the mixture separated by separating funnel, the components of the mixture should be immiscible. Okay, the components should be immiscible. So what do we mean when we say immiscible? So when using separating funnels, make sure liquids or components of the mixtures are immiscible. So liquids that do not mix. Immiscible liquids are liquids that do not mix. Different densities. Okay, so this is one of the criterion that we need to apply. So one of the liquids or one of the components should be denser than the other components, so that the denser can settle at the bottom. Denser component or liquid can settle at the bottom. Liquids must be immiscible. So this is one of the property that we need to consider. B, Roman numeral 2, suggest the names of two liquids that can be separated by the piece of apparatus shown in the diagram. Suggest the names of two liquids that can be separated by the piece of apparatus shown in the diagram. So the names of two liquids that can be separated by the piece of apparatus shown in the diagram. Let us look at these pairs. Okay, a separating funnel is a laboratory tool used to separate immiscible liquids to liquids that do not mix, such as oil and water, oil and water, oil and water, oil and water, kerosene and water, chloroform and water, ether and water, benzene and water. So these are immiscible liquids. They do not mix. Okay, they do not mix. So therefore, we are going to choose oil and water. Oil and water. We are done with the Roman numeral 2. Let us move to the next question. We move to the next question. We move to the next question. We move to the next question, which is the question. Question C. Suggest two precautions that need to be taken to separate the mixture in B Roman numeral 2. So the two precautions that need to be taken when separating mixtures using separating funnel. Make sure that the tap is closed before pouring the mixture. Okay, if it's open, the liquid will spill out. Number 2, allow the liquids to settle completely into layers before separating. This helps you to avoid mixing them again when draining. So these are some of the precautions, or these are two precautions that we need to consider when using the separating funnel. These are two precautions that we need to consider. Okay, so therefore we are going to say make sure the tap is closed. Make sure the tap is closed. Allow the liquids to settle completely into layers. So these are precautions that we need to consider when using separating funnel. Without wasting time, let us move to the next question. We move to the next question, which is the question B3. Question B3 reads, the following diagram shows the electronic configuration of the ion of an element M. Question A, Roman numeral 1. Draw the atomic structure and write the electronic configuration of the neutral atom. Remember, the electronic structure that has been given is that of an ion. We can see a cation, a positive charge, positive 2 charge here. So this one implies that this element has lost 2 electrons. So it had two more electrons in the outermost shell. Now it has lost these 2 electrons. So let us count the number of electrons shown here. So we have the first 2 electrons in the first shell and the second 8 electrons in the second shell, and the third 8 electrons in the third shell. So 2 plus 8 is equal to 10. 10 plus 8 is equal to 18, plus the 2 electrons that have been lost is equal to 20 electrons. So this element has 20 electrons. So if we check from our periodic table, an element with 20 electrons, is calcium. Okay, so we are going to say this is, we are going to draw 4 shells. 2 electrons in the first shell, 8 electrons in the second shell, also 8 electrons in the third shell, and 2 electrons in the outermost shell. So as we can see, we have successfully managed to come up with the electronic structure of the neutral atom of M. And the electronic configuration of neutral atom of M is 2, 2, 8, 8, 2. Okay, so this is the electronic configuration of M. This is the electronic configuration of M. We move to the next question. So according to our periodic table, this is the calcium here. So we can see that calcium has 20 as its proton number. Number. Okay, so this is calcium. This is calcium. The next question, give the name, group, and period of element M. So calcium, so the element we are talking about is calcium. Where is calcium coming from? Calcium is coming from group 1. Calcium is coming from group 1. So we are going to say group 1. The period, calcium is coming from period 4. Calcium is coming from period 4. We are done with the question B3. Let us move to question. So we are not yet done. We move to B. Compare the reactivity of an atom of M and an atom of compare the reactivity of an atom of M and an ion of M. Okay, so an atom of M, we are simply talking about a neutral atom, and an ion, we are simply talking about calcium that has lost 2 electrons. Okay, so ladies and gentlemen, we need to remember that calcium atom is reactive because it has tendency to lose 2 electrons to become stable. Okay, on the other hand, calcium ion is not reactive because it has already lost 2 electrons. So therefore this one is stable. So calcium ion is stable, is not reactive. So the one that is reactive is calcium in neutral state. So this one is more reactive. So calcium atom is more reactive because it has tendency to lose 2 electrons to become stable. While calcium, an ion, is not reactive because it has already lost those electrons and is stable. Okay, so we have compared atom of M and an ion of M. We are done with this question. Now let us move to the next question. We move to the next question, which is question B4. Question B4, salts are substances that have main methods of preparation. Question A, iron 2 chloride can be prepared by reacting substance X and dilute hydrochloric acid. Which reactant should be in excess? Okay, so the substance that should be in excess is ion metal or substance X. So substance X is the substance that should be in excess. Okay, substance X. Reason: using excess ion ensures all the hydrochloric acid reacts completely to which makes it easier to avoid contamination. So having excess substance X, make sure that all hydrochloric acid is reacted to avoid contamination. Then we need to filter out excess and unreacted ion. Okay, so therefore we are going to say substance X should be in excess, and this substance is ion metal. Roman numeral 2, why should the named reactant in A Roman numeral 1 should be in excess? So substance X should be in excess to avoid to make sure that all hydrochloric acid is reacted to avoid contamination. So the reason why substance X should be in excess is to make sure that all hydrochloric acid is reacted to avoid contamination. We move to the next question, which is question B, Roman numeral 1. Suggest a suitable reactant as substance X. So the suitable reactant as substance X is ion metal. Why are we saying ion metal? We can see that the product produced has ion. So therefore, the suitable reactant is ion metal. We move to B Roman numeral 2. Write a balanced chemical equation for the reaction between substance X suggested in B Roman numeral 1 and dilute hydrochloric acid So we are going to say ion plus hydrochloric acid is equal to ion chloride plus hydrogen. So guys, if we remember very well, last time we looked at how we can construct chemical equation. So before looking at how we can construct a chemical equation, we looked at 20 reactions, and one of the reaction was saying acid plus metal is equal to salt plus hydrogen. So we can see that acid plus metal is equal to salt plus hydrogen. Okay, so we are going to say ion plus hydrochloric acid is equal to ion chloride plus hydrogen gas. Okay, plus hydrogen gas. We need to balance this chemical equation. We can see that we have one atom of iron here, one atom of iron here, one atom of hydrogen, two atoms of hydrogen. So we have seen that atoms of hydrogen are not balanced. We need to do something here. We write 2 here. 2 atoms of hydrogen, 2 atoms of hydrogen. Okay, 2 atoms of chlorine, 2 atoms of chlorine. So we can see that we have come up with a balanced chemical equation. We are done with this question. Let us move to the next question. We move to the next question, which is question B5. Question B5, 10.5 grams of sodium hydroxide was reacted with dilute sulfuric acid according to the equation given here. Question A, balance the given equation. So this is neutralization reaction. So remember we looked at 20 reaction, and neutralization reaction was on number 5. Okay, neutralization reaction was on number 5. So we are going to write down this reaction. Here. we write down this reaction. We write down this reaction here, then we are going to balance it. We are going to balance it. Okay, here we go. So we can see that we have one atom of sodium here, two atoms of sodium. So what do we need to do? We write two here. We write two here. Two atoms of sodium, two atoms of sodium. The equation is balanced. We move to the next element. Two atoms of oxygen here, four atoms of oxygen. So 2 plus 4 is equal to 6. So we can see that we have 6 atoms of oxygen on the left part of the equation. Then we have 4 atoms of oxygen here, 1 atom of oxygen. So we have 5 atoms of oxygen on the right part of the equation. So therefore we need to do something. We are going to write 2 here. 2 atoms of oxygen, 4 atoms of oxygen, 6. 6 atoms of oxygen, 6 atoms of oxygen. We move to the next element. We have 2 atoms of hydrogen, 2 atoms of hydrogen. So we have 4 atoms of hydrogen on the left part of the equation. And we have 4 atoms of hydrogen on the right part of the equation. So we can see that atoms of hydrogen balanced. We move to the next element, which is the sulfur. We have 1 atom of sulfur, 1 atom of sulfur on the left part of the equation, 1 atom of sulfur. So therefore, we have seen that the equation is balanced. The equation is now balanced. Let us move to the next question. We move to the next question, which is B, Roman numeral 1. Using the balanced chemical equation to calculate the mass of sodium sulfate formed. Use the balanced chemical equation to calculate the mass of sodium sulfate formed. So this is what we are going to do to calculate the mass of sodium sulfate. So this is a balanced chemical equation. So we are going to use this ratio: sodium hydroxide and sodium sulfate. So we can see that here we have 2, here we have 1. So the ratio is 2 to 1. Okay, the ratio is 2 to 1. We are going to say therefore the number of moles is equal to mass divided by molar mass. Okay, the number of moles is equal to mass divided by molar mass. So the molar mass of sodium hydroxide is 40. The mass has been given, which is 10.5. Let us say 10.5 divided by 40. 10.5 divided by 40 is equal to 0.2625. So this is the number of moles. The number of moles of the number of moles of sodium hydroxide. Now we are looking for the number of moles of sodium sulfate. So once we find the number of moles of sodium sulfate, then it will be easier for us to find the mass. We do a cross multiplication. We are going to say x, 2 times x, we are going to get 2x. 1 times 0.2625, we are going to get 0.2625. Here divide by 2, even here divide by 2. Okay, even here divide by 2. So this 2 and this 2 cancel, then we are going to remain with x. The value of x is equal to 0.13125 moles of sodium sulfate. Now let us find the mass. So to find the mass, we are going to say number of moles is equal to mass divided by molar mass. Where there is number of moles, we are going to write 0.13125 number of moles divided by 142. We do a cross multiplication, we are going to get 18.6 63375. We round off. Mass is equal to 18.6 grams. So this is the mass of sodium sulfate. This is the mass of sodium sulfate. We are done with this question. Let us move to the next question. We move to the next question, which is the question B, Roman numeral 2. What type of reaction is involved in the equation? So the type of reaction involved in the equation is a neutralization reaction. So why are we saying neutralization reaction? So this is neutralization reaction because it involves acid and base. Sodium hydroxide is a base. Then sulfuric acid is an acid. So the reaction between base and the acid is called neutralization reaction. It's called neutralization reaction. We move to the next question, which is the question B6. An element A is in group 1 of the periodic table. Another element N is in group 7. Write property of the compound formed when element A and N react. So we are told that element A is coming from group 1 and the element N is coming from group 7. Okay, so the compound that will form from the element coming from group 1 and element coming from group 7 is ionic compound. Okay, is ionic compound. So we are going to give the physical properties of ionic compounds. Number 1, they are made up of positively charged and negatively charged ions. Number 2, they have high melting and boiling points because of strong electrostatic forces of attraction between ions. Number 3, they are soluble in water but insoluble in organic solvents such as ethanol and petrol. Number 4, in aqueous solution or molten states, they conduct electricity because the ions are free to move. Number 5, they are non-volatile and generally solids at room temperature. Okay, so these are some of the physical properties, and we have been asked to give one property of the compound. So the compound we are talking about here is ionic compound. They have high melting and boiling points. We move to the next question, which is question B. What type of bonding exists in the compound formed when the two elements react? So ionic bonding. So the type of bonding is ionic bonding. We move to C. How does the reactivity of elements in group 1 differ from that of elements in group 7? Okay, so in group 1, reactivity increases as you go down the group, while in group 7, reactivity decreases as you go down the group. We have given the difference. So as you go down the group in group 1, reactivity increases. As you go down the group in group 7, reactivity decreases. Okay, we are done with the question B6. Let us move to question B7. Question B7, a metallic bonding accounts for most of the physical properties of metals. A, with the reference to metallic bonding, explain why most metals have high melting points. Okay, explain why metals have high melting points. Ladies and gentlemen, before answering this question, we need to remember that most metals have high melting points because of strong metallic bonds. These bonds form between positive metal ions and localized electrons, and a lot of heat is needed to break them down. Okay, So therefore, we are going to say most metals have high melting points because of strong metallic bonds. These bonds are formed between positive metals and localized electrons, and they need a lot of energy to be broken down. We move to B. Draw a diagram to show a metallic bonding in zinc metal. So remember, zinc has valence 2. Okay, zinc has valence 2. So we are going to begin by drawing the positive the positive charges. Then also draw the negative charges. Also draw the negative charges. These are delocalized electrons. The negative charges are delocalized electrons. So we have drawn the metallic bonding in zinc metal. We have drawn metallic bonding in zinc metal. We move to the next question, which is question C. A learner carried out the following experiments. In experiment 1, 5 grams of powdered zinc, and in experiment 2, 5 grams of granules of zinc were each reacted with equal volumes of dilute hydrochloric acid, both of the same concentration, for 15 seconds. The reaction were not yet completed at 15 seconds. See Roman numeral 1, in which experiment was a large volume of hydrochloric acid produced. Give a reason for your answer. Give a reason for your answer. Okay. So to answer this question, we need to remember that powdered solids have a much greater surface area compared to granules. Therefore, the reaction will be faster with powdered substances than with granules. Okay, the experiment using powdered will result in a faster reaction than the one using granules. So the one with powdered will be faster than the one with the granules. So here we can see that we have one granule. Here we have powdered particles. Powdered particles. So therefore, we are going to say in experiment 1, a large volume of hydrogen was produced because powdered solids have a much greater surface area than that quicken the reaction compared to granules. So powdered, the reaction involving powdered zinc will be faster. So therefore, a huge volume of hydrogen will be produced. We move to Roman numeral 2. What would be the effect of reducing temperature of the acid in the reaction? Reducing the temperature of the acid in the reaction. Reducing the temperature of an acid in a reaction generally slows down the reaction rate. Okay, because particles moves slower at a lower temperature. Okay, at a lower temperatures, this leads to fewer collisions per second between acid particles and the other reactant like metal or carbonate. Also, fewer collisions have the required activation energy to cause a reaction. As a result, the reaction becomes slower when the acid is colder. When the acid has low temperature, so to say. Reducing the temperature of an acid in a reaction would slow down the reaction rate. Okay, so the reaction rate would slow down. We are done with this question. Let us move to the next question. We move to the next question, which is question B8. Question B8. The following diagram shows a laboratory preparation of a gas and its collection. Question A, identify Roman numeral 1 error in the setup in the diagram above. So which error was made here? So the error that was made, this funnel is supposed to be dipped in the hydrochloric acid, like the way they have dipped funnel here. So funnel should be dipped in liquid like this one. So we can see that here funnel is just hanging above the liquid. So this funnel should be dipped in the liquid. So we are going to say funnel is supposed to be dipped into the hydrochloric acid. Roman numeral 2 gas X. Roman numeral 2 gas X. So the types of reactions. Remember, I talked about the reactions. Last time we looked at 20 reactions. So reaction number 14 that we looked at is acid plus metal reaction. So acid plus metal reaction is equal to hydrogen, or a metal react with acid to produce salt and hydrogen gas. Okay, hydrogen gas. So therefore, the gas that will be produced here is hydrogen. We move to B, predict what would be observed if metal Y is placed with copper. Predict what would be observed if metal Y is replaced with water, with copper. Okay, so no reaction would be observed. Reason being, copper is non-reactive with acid. Copper is not reactive with acid, so no reaction would be observed. C, with the reference to air pollution, compare the use of ethanol and diesel. So ethanol produces less carbon monoxide, while diesel produces more carbon monoxide when they are both burnt. Okay, so we have seen that when we burn ethanol, less carbon monoxide will be produced. So we know that carbon monoxide is a pollutant. It is capable of causing pollution in our environment. So burning of ethanol will produce less carbon monoxide. Burning of diesel will produce more carbon monoxide, which is a pollutant. Okay, which is a pollutant. We are done with the question B8. Let us move to the next question, which is question B9. Question B9, the following table shows some of the fractions of hydrocarbons obtained from fractional distillation of crude oil. So the first column we have fractions, the second column we have boiling range. Question A, which fraction contains the longest chain? Give a reason for your answer. Give the reason for your answer. So before we answer this question, we need to consider this. The boiling point of hydrocarbons depend on molecular size. Okay. More carbon atoms, higher boiling point. Type of hydrocarbons, straight chain alkanes, boiling higher than blunt ones. So hydrocarbons with a straight chain have higher boiling points than blunt ones. Okay, so therefore we have seen that the one that will have the longest chain is this one with the higher, or with the highest boiling point. So the one with the one with um, the one with the highest boiling point is the one with the longest chain. So our correct answer is D, because it has the highest boiling point range. We move to B. Decane can be cracked to produce hexane and one other hydrocarbon, T. Roman numeral 1, deduce the chemical formula of T. Deduce the chemical formula of T. So the chemical formula of T is this one. Why are we saying this one? Why are we saying this one? So we can see that the one that has been cracked. Remember, there was a question that came. Cracked, I said cracked means breaking down hydrocarbons. So this one has 10 atoms of carbons. And here we have 6 atoms of carbons. So we can see that 4 atoms of carbons are missing. Then we have 22 atoms of hydrogen. Here we have 14 atoms of hydrogen. And we can also see that 6 atoms of hydrogen are missing. So no wonder we came up with this chemical formula. Okay, we are done with this question. Let us move to the next question. Draw the displayed structural formula of T. Draw the displayed structural formula of T. So they want us to draw the structural formula of T. So we are going to say carbon, this one is bonded to hydrogen, 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 bonded to one hydrogen, bonded to 2 hydrogen atoms. So we have come up with the structural or displayed formula. So this is the displayed formula of T. Okay, we move to the next question, which is the Roman numeral 3. Would you expect hydrogen carbon T to undergo polymerization? Explain your answer. Yes, T can undergo polymerization. Reason being, it has a double bond. So therefore, because of this double bond, it is more reactive. Because of this double bond, it is more reactive. So we are going to say hydrocarbon T can undergo polymerization. Reason being, T is an alkane like butene and contains a carbon to carbon double bond. So during polymerization, the double bonds break and the molecules join together to form a long chain polymer. Alkenes can easily undergo additional polymerization because of their reactive double bonds. Okay, because of their reactive double bonds. So therefore, we are going to say hydrocarbon T can undergo polymerization. Can undergo polymerization because hydrocarbon T is an alkene with double bond. Is an alkene with double bond. So the double bond is the one that is making it more reactive to undergo polymerization. To undergo polymerization. Ladies and gentlemen, we now shift to section C. We now shift to section C. Answer any 2 questions from this section in the separate answer booklet provided. Okay, so since we are revising this paper, we are going to answer all 3 questions from this section. Question C1, chemistry plays a big role in industry. A, explain how chemistry is used in water water treatment plant. So they want us to give the application of chemistry in water treatment plant. Chemistry is used in water treatment plant by adding chemicals. Chemistry is used in water treatment by adding chemicals. So the reason why they are adding chemicals is to remove dirty, kill germs, adjust pH, remove harmful substances. Okay, so therefore we are going to say chemistry is used in water treatment by adding chemicals to remove dirty, kill germs, adjust pH, and remove harmful substances. So the application of chemistry here is the addition of chemicals like chlorine, So chlorine is added to water so that it can kill the bacteria found in water. So this is the very application of chemistry. Without wasting time, let us move to the next question. We move to the next question, which is question B, Roman numeral 2. If the mineral water was put, okay, we come to this one. Explain how chemistry is used. Sorry. Figure 2.1 shows a label from a bottle mineral water called Amenshi Vumi pure water. Okay. Amenshi Vumi pure water. Ingredients: chloride ion, sodium ion, magnesium ion. pH 7.4. Question B, Roman numeral 1. State why Amenshi Vumi pure mineral water is not actually pure water. So, let us consider this. Amenshi Vumi pure water, Amenshi Vumi pure mineral water is not actually pure because it contains dissolved ions like chlorine ions, sodium ions, magnesium ions, and we can see that the pH of the water, according to the label given, the pH is slightly higher. So pure water should have the pH of 7. Pure water should be the pH of water should be neutral. Okay, the pH of water should be neutral, but we have seen that it is slightly higher than 7, which is 7.4. So therefore, Amenshi Womi pure mineral water is not pure. Pure water should contain only water molecules with no dissolved salts, ions, or impurities. Okay, or impurities. So therefore, we are going to say Amenshi Womi pure mineral water is not actually pure mineral water because it contains dissolved ion like chlorine ions and magnesium ions We move to the next question, which is the question B, Roman numeral 2. If the mineral water was put in a fridge, suggest the temperature at which it would freeze. Okay, suggest the temperature at which the temperature would freeze. Okay, so we need to understand that the basic units of matter found in the Amenshi are pure mineral water, atoms, atoms and ions. Atoms and ions. So therefore, we have skipped one question, sorry. We have skipped one question, which is here. If the mineral, if the mineral was put in a fridge, suggest the temperature at which it would freeze. So, ladies and gentlemen, we need to remember that pure water freezes at 0 degrees Celsius. This is not pure water. This is not pure water. It will freeze slightly lower than 0 degrees Celsius. Okay, it will freeze at a slight temperature than 0 degrees Celsius. We move to see what are the basic units of matter found in the mineral water which has the label shown. Okay, so the basic units of matter found in the Amenshi Vumi pure mineral water are atoms and ions. Atoms and ions. So therefore, we are going to say atoms and ions are basic units found in mineral water. So guys, here remember the answer is that since Amenshi Vumi mineral water is not pure, it will freeze slightly lower than the freezing point, which is 0 degrees Celsius. Okay, slightly lower than that temperature. Okay, we move to the next question, which is question D. Most metals exist. Most metals exist as compounds in their ores. Copper is extracted from its ore copper to sulfide. Give an outline of the stages of copper production. So they want us to give the stages involved in the copper production. Number one, mining. Copper 2 sulfide ore is dug from the ground. Number two, concentrating. Number two, concentrating ore is crushed and cleaned to make it richer in copper. Number three, roasting. So what is involved in roasting? Copper 2 sulfide is heated in air to form copper oxide and sulfur dioxide gas. Number three, reduction. Number three, reduction. Copper oxide reacts with the copper sulfide to produce pure copper metal. Number five, purification. Copper is purified using electrolysis or using electricity. So these are some of the steps that we need to consider. So therefore, we are going to say number one, mining. Copper sulfide is dug from the ground. Number two, concentrating. Ore is crushed and cleaned to make it richer or concentrated in copper. Number three, roasting. Copper 2 sulfide is heated in air to form copper oxide and sulfur dioxide gas. Number three, reduction. Copper oxide reacts with the copper sulfide to form pure copper metal. Or we can say copper oxide is reduced to pure copper. Copper oxide is reduced to pure copper. The last stage, purification. Copper is purified using electrolysis. So these are some of the stages. The question is carrying 4 marks. As we can see, we have provided the information that is equivalent to 4 marks given at the end of the question. Let us move to the next question, which is question D, Roman numeral at 2. Explain why copper conducts electricity. Explain why copper conducts electricity. So copper conducts electricity because it has free moving electrons that carry electric current. So the reason why copper conducts electricity is because it has free moving electrons that carry electricity. We are done with the question C1. Now let us move to question. We move to question C2. Question C2, Elena added excess calcium carbonate to 50 cubic centimeters of 0.10 mole per cubic decimeters of dilute hydrochloric acid. C2A, construct a balanced chemical equation for the reaction. Include state symbols. The question is carrying 2 marks. Okay, the question is carrying 2 marks. So the type of reaction we are talking about here is acid plus metal carbonate, and it is on number 15 according to the lesson that we had last time. Okay, so acid plus metal carbonate is equal to salt plus carbon dioxide plus water. Okay, an acid reacts with the metal carbonate to form salt, carbon dioxide, and water. Example, hydrochloric acid reacts with the calcium carbonate to form calcium chloride, carbon dioxide, and water. Okay, so the first question is saying construct the balanced chemical equation. So to construct the balanced chemical equation, we are going to say calcium carbonate plus hydrochloric acid is equal to calcium chloride plus carbon dioxide plus water. Okay, let us come up with the chemical formula of calcium carbonate. remember calcium is coming from group 2 and it has valence 2. Carbonate is coming from valence 2 and it has valence 2. So these two come here and these two come here. Then we are going to have this chemical formula. So we are going to say calcium carbonate plus hydrochloric acid is equal to calcium chloride plus carbon dioxide plus carbon dioxide plus water. Let us balance this chemical equation. We have one atom of calcium, one atom of calcium. Atoms of calcium balanced. We have one atom of carbon, one atom of carbon. Atoms of carbon balanced. We have one atom, we have three atoms of oxygen, three atoms of oxygen, three atoms of oxygen. We have one atom of hydrogen, two atoms of hydrogen. So therefore we need to do something here. We write two here, two atoms of hydrogen, two atoms of hydrogen. So as we can see, we have successfully managed to come up with a balanced chemical equation. We are done with this question. Let us move to the next question. We move to the next question, which is question which is question B, Roman numeral 1. The volume of gas produced in the first 2 minutes is 24 cubic centimeters. Calculate the average rate of the reaction over the first 2 minutes in cubic centimeters per seconds. So the first thing that we are going to do, we need to remember that rate is equal to volume divided by time. Data collection. What have we been given according to our question? According to our question, we are looking for rate. Then volume has been given, which is 24 cubic centimeters. Then time has been given 2 minutes. Now we are told that rate should be in centimeter cubic per seconds. So therefore, let us convert this one to we convert 2 minutes to seconds. So we need to remember that 1 minute makes 60 seconds and we have 2 minutes here. We do a cross multiplication. So we are going to say 1 times x is equal to x. 2 times 60 seconds is equal to 120 seconds. 120 seconds. So where there is volume, we write 24, then where there is time, 120. 24 cubic centimeters divided by 120 seconds, we are going to get 0.2 cubic centimeters per seconds. So this is our rate. We are done with this question. By the way, you are free to pause the video and assimilate the information given here. We move to the next question, which is B, Roman numeral 2. How would the learner remove excess calcium carbonate from solution in A? Okay, how would the learner remove? We have skipped one question. The learner repeated the experiment using 50 cubic centimeters of 0.01 mole per cubic decimeters of ethanoic acid, using the kinetic particle theory to explain why the rate of the reaction is lower with ethanoic acid than with hydrochloric acid. So they want us to give the reason. So according to kinetic particles theory, particles are always moving and reactions happen when particles collide with enough energy. Okay, hydrochloric acid is a strong acid, meaning it has more hydrogen ions freely moving around. Then ethanoic acid is a weak acid, meaning it has fewer hydrogen ions because it doesn't release OH ions. Okay, so because of this, when calcium carbonate reacts with hydrochloric acid, there are more collisions between hydrogen ions and calcium carbonate particles, and the collision have more energy. Okay. With the ethanoic acid, there are fewer collisions because there are fewer hydrogen atoms. In a layman language, we are simply saying hydrochloric acid is a strong acid, so therefore it dissociates completely. So dissociating completely means it is producing a lot of hydrogen ions. Then for ethanoic acid, ethanoic acid is a weak acid. It produces a limited number of hydrogen ions. So therefore the reaction is slower. Remember, there is a question we talked about concentration. So we have seen that hydrochloric acid will produce will make the concentration of hydrogen ions higher, thereby making the reaction to be fast. Then this one that is producing fewer hydrogen ions, the reaction will be slower. We move to Roman numeral 3. How would the learner remove the excess calcium carbonate from the solution in A? Okay, so these are some of the things a learner need to consider. Set up a filter funnel with the filter paper. Pour the mixture into the filter funnel. The liquid passes through the paper into a container below. The excess solid calcium carbonate stays on the filter paper. Okay, so therefore we are going to say set up funnel with filter paper, pour the mixture into the funnel, the liquid passes through the paper into a container below, the excess solid calcium and carbonate stays on the filter paper. So these are some of the steps that the learner need to consider to remove excess calcium carbonate from the solution. Okay, so calcium carbonate is insoluble. So no wonder we are using a filter paper. We move to question C. Methane is a greenhouse gas. What do you understand by the term greenhouse gas? So what is greenhouse gas? A greenhouse gas is a gas in the atmosphere that traps heat from the sun, keeping the earth warm. Okay, in simple terms, sunlight comes to earth and warms it. Greenhouse gases like carbon dioxide, methane, water vapor stops some of the heat from escaping back into space. This makes Earth's temperature higher, or it stabilizes Earth's temperature. So therefore we are going to say green gas is a gas in the atmosphere that traps heat from the sun, keeping the Earth warm. We are done with this question. Let us move to the next question, which is question C, Roman numeral 2. The percentage of methane by volume in the air is 0.00014%. Calculate the mass of methane in 1000 cubic centimeters of air at room temperature and pressure. The question is carrying 2 marks. So to answer this question, the first thing that we are going to do is to find the 0.00014% of 1000 cubic centimeters. Okay, so we are going to say 0.0014 times 1000. We are going to get 0.14. 0.14 divided by 100. We are going to get 1.4 times 10 to the power negative 3 cubic centimeters. So this is the volume of methane in air. This is the volume of methane in air. So what do we need to do next? Let us find the number of moles. So we are going to say the volume, we are from finding volume, which is 1.4 times 10 to the power negative 3. Divide by 24. Okay, divide by 24. Divide by 24, we are going to get 5.833 times 10 to the power negative 5. Okay, times 10 to the power negative 5. What have we been asked to find? To find the mass. So we have successfully managed to find the number of moles. Now let us find the mass. So where there is number of moles, we are going to say the number of moles is equal to 5.833 times 10 to the power negative 5. Then the molar mass of methane is 16 gram per mole. So where there is number of moles, we are going to write 5.8 times 10 to the power negative 5 times 16. We are going to get 9.33 times 10 to the power negative 4 grams. So this is our answer. This is our answer. Okay. We are done with this question. Let us move to the next question. We move to the next question, which is we move to the next question, which is question C3. Question C3 is our final question in this video, in this paper, so to say. Question C3, the following table shows the soil pH ranges required by different crops for growth. Okay, so the first column we have crop, peanut, millet, sunflower, paprika, mango. Then the second column we have pH range. Question A farmer plants peanut and millet crops. Only the peanut grows well. Roman numeral 1, predict the pH of the soil. Predict the pH of the soil. Okay, so we need to remember that from 1 to 6 on our pH is it shows it indicates acid. Then from 8 to 14 base. Then 7 is neutral. Okay, 7 is neutral. So peanut, let me read the question again. Maybe, let me read the question. The question is saying a farmer plants peanut and millet crops. Only peanut grows well. Predict the pH of the soil. So we have seen that only peanut grows well. Okay, only peanut grows well. So what could be the reason for okay, so we need to remember that peanut thrives or peanut grows well in the pH range 0.5 to 5.0 to 6.5, while millet requires the pH of 0.6, 6.0 and 6.0 to 6.5. So if millet fails to grow properly, the pH is most likely between 5.0 to 5.9, suitable for peanut, too acidic for millet. So the pH of millet is 6.0 to 6.5. Okay, and we are told that only peanut has grown well on this temperature. Okay, so it is obvious that the pH of millet is 5. the pH of millet is 5 to 9, suitable for peanut, but too acidic for millet. So therefore, we are going to say the pH of the soil is most likely between 5.0 and 5.9, suitable for peanut, but too acidic for millet. We are done with this question. Let us move to the next question. We move to the next question, which is question A, Roman numeral 2. Which other crop is most likely to grow well in the same soil? So we have predicted the pH of the soil, and we are from saying the pH of the soil is from 5.0 to 5.9. So we have seen that mango can grow well. Okay, mango can grow well in this pH. So we are going to say, since the pH of the soil is likely between 5.0 to 5.9, mango is most likely to grow well in the same pH, as it has the pH range of 5.5 to 6, which is here. So mango is most likely to grow well in this pH. We move to the next question, which is A, Roman numeral 2. Suggest what should be done to the same soil by the farmer in order for him to grow paprika. Okay, where is paprika? So the pH of paprika is 7.0 to 8.5. So this is the basic or alkalinity. This is basic or alkalinity. So what are we gonna say here? To grow paprika, the pH 7.0 to 8.5, the farmer should raise the pH by applying agricultural lime such as calcitic lime or calcium carbonate, or dolomitic lime, calcium magnesium carbonate, or using wood ash sparingly to increase alkalinity or to increase the basic nature of the soil. Okay, adding crushed eggshells for gradual pH increase. So these are some of the measures that a farmer needs to consider to reduce the pH, to increase the pH of the soil so that it can become suitable for paprika. Okay, it can become suitable for paprika. Or testing the soil regularly to monitor the pH. So therefore, to answer this question, we are going to say to grow paprika, pH, to grow paprika with pH 7.0 to 8.9, the farmer should raise the pH by applying agricultural lime such as calcium carbonate or calcium magnesium carbonate. So these are some of the measures that this farmer needs to consider to raise the pH of the environment where paprika can be grown. We move to B. Ammonium nitrate is one compound which is added to the soil by many farmers. Explain why ammonium nitrate is added to the soil. Explain why ammonium nitrate is added to the soil. Ammonium nitrate is a fast-acting nitrogen fertilizer. Okay, it supports plant growth, essential for proteins, chlorophyll, and DNA. Works fast, water soluble, ideal for crops like wheat and corn, maize. Balanced nitrogen release, immediate or gradual supply. Okay, so therefore we are going to say ammonium nitrate is a fast-acting nitrogen fertilizer. It supports plants growth. So the question is carrying 1 mark. The information given here is enough for 1 mark given at the end of the question. 1 mark given at the end of the question. We move to the next question, which is question C. The diagram shows part of nylon, a condensation polymer. Roman numeral 1, deduce the chemical formula of the two monomers in nylon. Deduce the chemical formula of the two monomers in nylon. Okay, so nylon is commonly made by condensation polymerization of two monomers, dicarboxylic acid and diamine. Okay, for nylon 6 to 6, the 6 to 6, the two monomers are xn 1,6 diamine, xn 1,6 diamine. The chemical formula H2N, H2N, then we have xn, H2N, xn, xn dioic acid, xn dioic acid or dicarboxylic acid. The chemical formula, so this is the chemical formula. These two monomers react to form nylon and water. They react to form nylon and water. Deduce the chemical formula. So the chemical formula of diamine is this one. Okay, then the chemical formula of dicarboxylic acid is this one. So this is the chemical formula of dicarboxylic acid. The chemical formula of dicarboxylic acid. We move to the next question, which is the question C, Roman numeral 2. Draw the displayed molecular structures of the two monomers. So the displayed formula, we are simply asked to draw the structural formula. To draw the structural formula. So to draw the structural formula, this is what we are going to do. To draw the structural formula, let us begin with the structural formula of diamine. So to draw the structure of the formula of diamine, we are going to start with the xn. Okay, we are going to start with xn. So each carbon is surrounded by 4 bonds. Surrounded by 4 bonds. Okay, or we can draw it like this. Can draw it like this. Okay, so this box is representing what is in the bracket here. This box is representing what is in the bracket here. Or we can say this box is representing what is representing this. This box is representing this. Okay, so as we can see, this is how we can draw the electronic structure. This is how we can draw the electronic structure of diamine. Let us also draw the electronic structure of dicarboxylic acid. So to draw the electronic structure of dicarboxylic acid, this is what we are going to do. Okay, we have C double bond or single bond. Okay, so this is the structural formula. This is the structural formula or displayed formula of dicarboxylic acid. Here also this box is representing what is in the bracket here. Okay, representing what is in the bracket here. Okay, so we are done with this question. Let us move to the last part of this question. We move to the last part of this question. Fishnets used to be made from natural fibers. Main nets are now made from nylon. Suggest one advantage and one disadvantage of using nylon rather than natural fibers to make fishnets. Okay, so our answer is number 1, advantage. The advantage of using nylon is stronger and lasts longer than natural fibers. So the fishnet won't break easily. So this is the advantage. Disadvantage. Nylon does not rot or break down or decompose or decay. So if it lost in water, it can cause pollution and harm animals. So since this one is difficult to decompose, it may cause pollution. It may cause pollution in water. Okay, it may cause water pollution, or it may make the lives of aquatic organisms difficult. So, ladies and gentlemen, we have come to the end of this video. So, if this video is valuable to you, you may consider subscribing to my channel or follow my page. Thank you very much for watching this video once again.